first bit. In first bit, use Euclid division algorithm. Use Euclid division algorithm to find HCF of following questions. In this first question, 900 into 270. This is first question. Second question, 196 and 38,220. Third question, 1651 and 2032. These are first bit questions. First bit 3 questions. Using division algorithm. This is a using division algorithm, just like in example 1 also. Now I will explain the first problem. Remaining 2 problems is a homework problem. Okay. Now listen. First of all is mentioned in that question using division algorithm. Using division algorithm, A is equal to B cube plus R. Here A comma B is a positive integers. Yes, it is a positive integers. Here values is 0 less than or equal or less than B. R means remainder. R means remainder. Here B, here for example, here this is a 3. Here 3. Here 12. A is equal to B cube plus R. Right. Here 3, 4 on. Here in first problem, given numbers. In given numbers, 900 and 271. These are positive integers only. Here which is the biggest number? 900 is the biggest number. 900 by 271. 900 by 270. Right? Here 270. Here 900 is 4 table. One check it. 4 table. 27 4 0. 7 4 28. 8 will be 3 table. 2 1 only. 6 8 8 3 27 3 8 1 0. 3 7 21 2 and 1 only. 3 2 6 6 plus 2 8. Remaining is 91. Next remainder is not getting the 0. Now continuous. 270 right here. Next 9 3 is 27. 9 3 is 27. Means 271. We will get the remainder 0. This is the HCF value. The HCF of 900 and 270 is 90. Right? Steps also. Step 1. Divided 900. Divisor 270. Quotient 3. Remainder 91. Step 2. In step 2, dividend 270, divisor 90, quotient 3, remainder 0. The HCF of these two numbers is 91. Same procedure apply in the remaining 2 problems also. The 2 problems is homework. Very easy. This is maybe is given a 2 marks question only. Using division, directly is mentioned in that question, using division algorithm only. This method is up to remainder 0 only. Up to remainder is 0. Now next to remaining 4 problems, very important in the board exam. 6 marks, very important questions. Yes, 4 problems, very important. Now I will explain the first problem. Remember, using division algorithm, the algorithm formula A is equal to BQ plus R only. Remember. Condition 0 less than or equal R less than B1. The condition is using in the second, third, fourth problem. Second, third, fourth problem. 6 marks, very, very important questions. Right, first question. Exercise 1.1. First bit 3 problems. Now second question. Using division algorithm to show that using division algorithm to show that any positive odd integers, any positive odd integers is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Here q some integers only. This is a question. In exercise 1.1, first bit HCF of Euclid division algorithm is completed. Now second problem also using division algorithm also completed. Now in the third problem using division algorithm to show that sphere using division algorithm. The division algorithm is A is equal to BQ plus R, condition 0 less than or equal R less than B1. This is a Euclid division algorithm condition. In the third problem using division algorithm, this is a division algorithm to show that sphere, underline the sphere of any positive integer is of the form 3p or 3p plus 1, p some integer only. This is a question. Now third question answer. Third one is mentioned that sphere of using division algorithm. In this problem, LHS and RHS is mentioned in that formula, but is not mentioned in the LHS and RHS. Now mention let A is equal to 3p is compared with same as the problem is compared with A is equal to BQ plus R. Here A is equal to A, B is equal to 3, P is equal to Q, R is equal to 0. Without any number, please consider the 0. Right? A is equal to A, B is equal to 3. Next, Q is equal to P, R is equal to 0. First compare is complete. Second one is mentioned let A is equal to 3P plus 1 is compared with A is equal to BQ plus R. A is equal to A, B is equal to 3, Q is equal to P, R is equal to 1. Right? A is equal to A, B is equal to 3, Q is equal to P, R is equal to 1. Here compare is completed here. Now next one is in the question is mentioned sphere. Sphere means right sphere of A is equal to 3p1. Squaring on both sides. Squaring on both sides. Right here A square is equal to 3p whole square is equal to 3 square and p square. 3 square means multiplication of 2 times. 3 3 is 9. 9p square. First square is completed. This is a perfect square number. It mentions square positive. Second one is A is equal to 3p plus 1. A is equal to 3p plus 1 is also mentioned squaring on both sides. Why? Because it directly In that question, square only. Squaring on both sides. Right here, a square is equal to 3b plus 1 whole square. Here, this is a formula a plus b whole square formula. A plus b whole square is equal a square plus 2ab plus b square. Right here, a is equal to 3p only. 3p whole square plus 2ab, 2 into 3p into 1. This is a, this is b1 plus b square means 1. 3 square write individually, 3 square and p square plus 2 into 3 6, 6 into 1 6p1 plus 1 square is equal to 1. 3 square, 3 is multiplication 2 times, 9p square plus 6p plus 1. This much only solution. Just write last point. Using division algorithm to show that. Remove this up to here. That square of any positive integer is of the form 3p comma 3p plus 1. This is the solution. Now listen, using division algorithm. This is a division algorithm. A is equal to bq plus r1. Right? In that formula, A is equal to bq plus r1. Here LHS and RHS only. But in that question is not mentioned LHS and RHS. Right? A is equal to 3p only. Let only mention. Means 3p is equal to A1. A is equal to 3p. E is combined with same formula. Here also same as that. Additional second problem and third problem, additional part is a square only. This is a squaring on both sides, squaring on both sides only. One condition 0 less than or equal r less than b only. 0 less than or equal, here r is equal to first 0, next r is equal to here 1, less than b is equal to 3 only. 3 is a common number. Okay, this is a third problem. Now fourth problem. In fourth problem, using division algorithm, this is also same as the question only. A is equal to fourth solution. Here, using division algorithm to show that additional is q1. This is x square, this is a q1. Is of the form 9m, 9m plus 1 or 9m plus 8. Let is add to the 3. Let a is equal to 9m. Is compared with A is equal to bq plus r1. Here A is equal to A. Next B is equal to 9. Q is equal to m. R is equal to without any number means 0. Right. Next let A is equal to 9m plus 1. Is compared with A is equal to bq plus r1. Here A is equal to A, B is equal to 9, Q is equal to M, R is equal to 1. Last compare. Let A is equal to bq plus r is compared with A is equal to bq plus r1. A is equal to 9m plus 8. 9m plus 8 is compared with A is equal to bq plus r1. Here A is equal to A, B is equal to 9, Q is equal to M, R is equal to 8. Compare is completed. Then additional bit is cube only. What is first number? A is equal to 9m. The cube of both sides. The cube of both sides. Here write a cube 9m whole cube is equal to 9 cube and m cube. 9 cube means 9 is multiplication 3 times. 9 9 ja 81. 81 9 ja. 9 1 ja 9. Next 72. 729 m cube. Okay, this is cube completed. One more is 9m plus 1 more. A is equal to 9m plus 1. The cube of both sides. The cube of both sides. The cube of both sides. A cube is equal to 9m plus 1 whole cube. Here one formula. A plus b whole cube formula. Here a cube plus b cube plus 3a square b plus 3a b square. Now substitute as usually 9m whole cube plus 1 cube plus 3a square means 9m whole square into 1 plus 3 into 9m into 1 square. Here already 9m cube is completed here only. 729 m cube plus 1 cube is 1 plus 9 square means 81. 81 into 3. 81 3. Here 3 243. 243 m square plus 3 9 27. 27 m. 1 square is 1 only. 27 m only. Next remaining also same as usual is completed. Therefore 0 less than or equal or less than 0. 0 less than or equal. R is equal to first to 0, next to 1, next to 8 less than. B is equal to 9. Last point as usually. Therefore remove using division algorithm to show that the square of the cube of any positive integer is of the form right 9m, 9m plus 1 and 9m plus 8. This is a fourth problem. Second problem, third problem, fourth problem, same procedure only. But third problem is square, next fourth problem is cube. Last problem, that is fifth problem. Show that 190 only 1 only, not using division algorithm. 190 only 1 out of n comma n plus 2 comma or n plus 4 is divisible by 3. These three number, only one number is divided into 3 only, where n is a positive integer. Positive integer means indirectly natural numbers only. Right? 190 only 1 out of n comma n plus 2 or n plus 4 is divided by 3. N belongs to positive integers. Positive integers means indirectly natural numbers. First natural number n is equal to 1 substitute here. Here 1 is does not divide in the 3 table. Next 1 plus 2 is equal to 3. 3 by 3 is divisible. Next write here 1 plus 4 is equal to 5. 5 does not divide in the 3 table. In this line only one number is divided. Now check it one more number. 2. Here 2 by 3 only does not divide. Here 2 plus 1 is 2. Total 4. 4 by 3 is does not divide. Here 2 plus 4 total 6. 6 by 3 only. Yes, it is divisible. This procedure is continuously. Therefore, observe in the first line, second line, only one number is divisible by 3 table only. Remaining is does not divide in the 3 table only. Yes, it is possible in the natural numbers. Therefore, in that show that 190 only 1 out of n comma n plus 2 or n plus 4 is divisible is divisible by 3 only, comma n is a positive integer. This is a fifth problem. Now listen, in exercise 1.1, first bit 2 marks is very important, using division algorithm to find the HCF one. Second problem, third problem, fourth problem, using division algorithm. Just to remember, a is equal to b cube plus r, condition 0 less than or equal r less than b only. Fifth problem, quite different between second, third, fourth only. This is a one more type of question. Just mention in the already question, n comma n plus 2 or n plus 4 is divisible by 3. N is a positive integer. The integer positive means indirectly natural number. Just substitute in the n place is 1, 2, 3, 4 up to infinity only. Just one to one substitute, two substitute, and one more 3 also possible. Next 4. Then just write, mention in the infinity symbols. Then write the last point only.